Hello everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In the last session, we have discussed about the what is maximum power transfer theorem and what kind of statement behind the maximum power transfer theorem, and how do we derive the condition for maximum power value. So these things we have determined in the last session. I mean, we have discussed in the last session. So in this session, we are going to discuss about the different numericals based on the maximum power transfer theorem. So let us take a problem number 1. So in the question they are going to clearly mentioned. So need to find out the RL value. I mean, here RL is unknown thing, and after the finding out the RL value, so we need to determine the maximum power across the load resistor. So for this, so every circuit we already discussed it in the last session. So need to apply the maximum power transfer theorem to any circuit. So we would like to determine the whole circuit with the Thevenin's equivalent circuits. So need to determine the Thevenin's equivalent circuit. So in the Thevenin's equivalent circuit means, so we would like to apply the Thevenin's theorem to determine the VTH of the circuit and also RTH of the circuit. So then only we would like to apply the maximum power transfer theorem to get the maximum power value. So this is the briefing about this problem. So there are the different conditions to get the Thevenin's equivalent circuits. So for that we need to determine, we need to find out, or we need to determine. So the first case, so need to determine, they need to replace the whole circuit with the Thevenin's equivalent circuit like this. So this is the VTH, or also we can say V source. Then this one is a RTH, and this one is a RL. So this is RL. So it must be equal to the RTH or R internal. So this one is R internal, we can say. So need to replace the whole circuit with this kind of parameter. Means we need to determine the Thevenin's equivalent for this circuit. So for that need to find out the VTH and RTH. So need to go with the step number 1. So step number 1. So need to apply the Thevenin's theorem to the circuit. Step number 1 to find out the VTH. So how can we find out the VTH? We have already gone through the Thevenin's theorem. So to determine the VTH of any circuit, we would like to remove the load resistor from the load terminals. So this is the required circuit. This is the plus minus. So 36 volts. And this one is a 3 ohms, and this one is, I think it's a 15 ohms. So previously there is a load across the terminals, so we have removed. So how can we find the VTH? So to find or to determine the VTH, VTH, so we need to remove load resistor, which terminals are, we can say which terminals are keep like open circuit. So then only we will get the VTH. So how can we find the VTH? We already gone through that. Again, I am reminding that. So to determine the VTH of any circuit, we would like to remove the load resistor from the load terminals, and which terminals are keep as is or maintain as is. So whatever the value of resistance, whatever the value of voltage we got here, so that corresponding voltage is called as Thevenin voltage. We will like to get the voltage across these two terminals. That voltage is called open circuit voltage, also called as Thevenin voltage. So there are different techniques to get the voltage across this open terminals. So this open terminal voltage means, so which is same as the 15 ohm voltage. That means, so we need to find out the voltage across the 15 ohms. So V15 means it's a voltage across the 15 ohms. So how can we find the voltage across 15 ohm means, so we can we can apply the different technique like Kirchhoff law also we can apply to find the current, and then so we'll get the some current value, then across the 15 ohm resistor, then we will get the some voltage. That voltage is called as the Thevenin voltage. So we need to say the voltage across the 15 ohm is also same as the Thevenin voltage, that is VTH. How can I determine the VTH value means? So I am applying here the voltage division because it's a series circuit, so that we can apply the, so by using here by using voltage division rule, by using the voltage division rule, we would like to get the voltage across 15 ohms. So we can say it's a V15 ohms or VTH equal to the, so total voltage into same resistance by, it's a formula of voltage division rule. So same resistance upon total resistance, same resistance upon total resistance. So means the VTH of this corresponding circuit should be equal to the, it is the 36 volts is the total voltage, same resistance means, so at what element we need to get the voltage, that's called same resistance, that is the 15 ohms. So divide by, so 3 plus 15, which means 36 into 15 divided by, it is 18. So 18 ones and 18 to this one, we will get 30 volts. So therefore Thevenin's voltage of the above circuit should be 30 volts. So this is the VTH value. So then the second step, I mean now we have done about these of the first parameter, I mean this one, this value we got, means how will we get this value means based on this step, based on this procedure. And the second one, that is a step number 2. So how can we replace the whole circuit with the Thevenin's equivalent, means need to find out the Thevenin's equivalent circuit parameter, that is VTH and RTH. In that case we have already determined the VTH value. This is the way to get the VTH value. Then to replace the to determine the RTH of the circuit, then we would like to follow some kind of procedure. So that is step number 2. The step number 2 is find the RTH. So how can we find the RTH means? For the above circuit, so remove the load resistor, remove RL or load resistor, which terminals are key positives, which terminals are keep opened, and also deactivate the energy sources. So if it is a voltage source, so we can replace their internal resistance. If it is a current source, we can replace their internal resistance. So that is a open circuit. This one is the internal resistance of idle current source is a open circuit, and this one is a short circuit. The internal resistance of idle voltage source is infinity. We can replace that infinity with the short circuit path. So the corresponding circuit should be so like this. So this is the RTH procedure. So the circuit is going to be like this. So remove it and block it, close it. So this is a 3 ohm resistor and this is the 15 ohm resistor. At these 2 points we have the load element. So we have removed that load element. So whatever the resistor, whatever the equivalent value appear across the, open terminals, so that corresponding resistance is called open circuit resistance or Thevenin resistance or effective resistance of this combination. So how can we get this means RTH equal to the, so that is this is the way to get that value. So based on the current flow, these two are parallel to each other. So why should I consider the current here means to get the relationship, connection between the different resistor. We would like to connect a dummy source. The dummy source deliver the dummy current. Based on that, we would like to find out or determine the different resistor connections. So based on this analogy, so 3 and 15 ohms are in parallel. So 3 into 15 divided by 3 plus 15. So here 45 divided by the 18. 45 divided by the 18. Here 6 the, and here 15 is the, then 15 by 6 means it is a 2 by I think 2 by 5 here. So we got 2.5 ohms is the effective resistance of the above combination. So therefore RTH of the above circuit is a 2.5 ohms. So we have already find out the VTH of the circuit. I mean, we've already gone through the procedure about the VTH. Based on that, we'll get the based on that we got the VTH value, and based on the some procedure we got the RTH value. So by using these two parameters, using the so Thevenin's equivalent parameters, parameters. So need to draw the, we need to draw the so Thevenin's equivalent circuit diagram. That is step number 3. So this is step number 3 in the Thevenin's theorem. So to find out the required parameter, that is so power dissipated by the load element, and also the voltage across the load element, and also the current flows the load element. So for that we require to get the Thevenin's equivalent circuit based on the Thevenin's equivalent parameters. So that is, so this is the Thevenin's equivalent circuit parameters. So this is the VTH value, and this is the RTH value. This is the RL of the circuit. So this is RL of the circuit. So what is the VTH value of the circuit? So we got some value, that is based on the procedure we got some value. So that is based on some procedure we got the VTH and RTH value. So we try to mention that values here, then it will become easy to find the required things. So this is the VTH, that value equal to, we got it as 30 volts, VTH is 30 volts, RTH is a 2.5 ohms. So this is the load resistor, RL equal to the RTH, which means it's a 2.5 ohms. So this is the RTH and RL values. So in the question they are clearly asking the circuit shown below to find out the RL value. So here we have determined the RL value as 2.5 ohms, and also determine the maximum power across the load resistor. So based on the maximum power transfer theorem, we would like to find out the maximum power value. So there is a formula for maximum power value. In the last session we have derived that is VTH square divided by the 4 times of RL. Based on that one we got this formula. So we have already gone through the VTH and RTH, RL value. Therefore P max equal to the, so that is a 30 whole square, because VTH value is, so VTH equal to 30 volts, then RTH also we can see RL equal to 2.5 ohms. So based on these values we can find out the maximum power value according to the question. So that is a 4 times of 2.5 ohms. So therefore P max equal to the, we need to write this is the 30 into 30, so divide by 10, that is 4 to the 8, we'll get 10 only here. Based on this one we got the maximum power value. So therefore P max equal to the, so this is the 90 watts. So based on this procedure we would like to find out the maximum power value. So this is the end of the session. So in the session we have discussed about the how we would like to apply the maximum power transfer theorem to the different circuits. So how we would like to apply the maximum power transfer theorem for any circuit means, so we need to determine for any kind of circuit to apply the maximum power transfer theorem. So we need to determine the whole circuit with the Thevenin's equivalent circuits. So then only we would like to apply the maximum power transfer theorem to get the RL value and also the maximum power value. So this is the end of the session. So we will discuss in the next session. So that is the different numericals based on the maximum power transfer theorem. So this is the last session of the first module, and after that we would like to start the second module, that is the AC circuits. So this is the end of the first module, that is the first unit or first chapter in the basic electrical engineering. So that is the DC circuit. This is the end of the session. So thank you one and all, and thanks for watching this video.